Welcome, my friends. In this video, I'll be discussing section 3.3, which is titled Locating the Center. The most common ways to represent the center of a dataset or distribution is by using either the mean or the median. To find the mean, we simply add up all the numbers in our dataset and divide by how many values there are. But we would like a little bit more of a mathematical definition for the mean. If we're dealing with sample data, meaning we have a statistic, then we're going to be using the symbol x bar to represent the mean. To find x bar, we will add up all the numbers in our dataset, but mathematically, we can represent that by the sum of x. This symbol right here is the capital letter sigma, which tells us to add up or sum whatever is in front of it, which is all of the x values, or all the data values. And then we will divide by n, which is the sample size. As I just mentioned, this symbol here means sum, so we can read this as the sum of x. Let's say we have the data values 5, 5, 6, 7, 12, and 37. If that was the case, then the sum of x, the numerator in our mean calculation, will just be adding all those numbers together, which is equal to 72. Lowercase n is our sample size, which is 6, because there are 6 different numbers in our sample. Putting everything together, we can find the sample mean x bar by taking the sum of x, which is 72, and dividing by 6, which gives us 12. The sample mean is equal to 12. Note that in this case, we have the value 37, which could be considered to be an outlier. It's quite a bit larger than the other numbers in the dataset. The outlier of 37 skews the mean to the right, meaning it's going to make the mean a lot larger than it would be without it. For this reason, we say that the mean is sensitive to outliers. If we have outliers, then the mean is really going to be influenced quite a bit by those outliers. Let's talk about the median. The median is the value in the middle of an ordered dataset. Here is the same dataset that we had on the left. This dataset is already in order. Since we have an even number of values, there's not really a single value in the middle. There's really two values in the middle, which are both 6 and 7. Therefore, to find the median, we can find the mean of the two middle values. The mean between 6 and 7 is 6 plus 7 over 2, which is equal to 6.5. Notice that for the median, the outlier of 37 had very little effect. It doesn't really matter if we have any outliers for the median because the median kind of just crosses out the values at the extremes. So for this reason, we say that the median is resistant to outliers. Make sure you know how the mean and median are affected by outliers. The mean is sensitive to outliers, and the median is resistant to outliers. We say that the mean is the mathematical balancing point of a dataset, and the median splits the data set into two equal halves. Both of these values represent the center of a dataset, but in a slightly different way. Let's say that we have this dataset. We have the values 2, 3, 4, 8, and 10. If we wanted to find the mean, we could simply add up all the values and divide by how many there are. That means we can add up 2 plus 3 plus 4 plus 8 plus 10 and divide by n, our sample size of 5. We will get 27 over 5, which is equal to 5.4. The mean is equal to 5.4. The median, on the other hand, is the value in the middle. And since the values are already in order, the value in the middle is going to be the third value, which is 4. So the median is equal to 4. Now here's a new term for you. The deviation is represented by each value's distance from the mean. Basically, you can find each value's deviation by taking that value, x sub I, and subtracting the mean. You can think of the I as simply a placeholder that represents each of the different x values. So I is going to equal 1 for the first value, or 2 for the second value, etc. through all the values in our dataset. So let's go ahead and calculate the deviation for each of our values. The deviation for x1 would take x1 and subtract the mean. So we have 2 minus the mean of 5.4, which is equal to negative 3.4. This means that the value of 2 is 3.4 units below the mean. Let's now go on to the second value. The deviation for x2 is going to be 3 minus 5.4, which is equal to negative 2.4. 3 is 2.4 below the mean of 5.4. We can continue this for the remaining values. The deviation for x3 is negative 1.4, the deviation for x4 is 2.6, and the deviation for x5 is 4.6. Any positive deviations represent a value that is above the mean, and any negative deviations represent a value that is below the mean. Now, I mentioned earlier that the mean is the mathematical balancing point of a dataset. What does this mean? Well, this means that the deviations, which is the difference of each value to the mean, if summed together, will equal 0. As x bar is the balancing point of the dataset, the sum of all the deviations will always equal 0. So what does that look like? Well, if we take the sum of x sub I minus x bar, which is really just the sum of all of the deviations, that's going to be negative 3.4 plus negative 2.4 plus negative 1.4 plus 2.6 plus 4.6. And if we add those 5 numbers together, we will indeed get 0. That's what's meant by the mean being the balancing point of the dataset. If we add up all the deviations from the mean, we will get 0. Sometimes the mean is called the mathematical center because it is the balancing point of a dataset, based on this idea of deviations summing to 0. On the other hand, the median is literally the center of the dataset. It splits the data into 2 equal halves. The easiest way to see this is based on a little dot plot here on the number line. So the median is splitting the dataset in half in such that there is just as many values above the median as below the median. In this case, there are 2 values above, the 8 and the 10, and there are 2 values below, the 3 and the 2. The mean in this case ends up being a little bit higher than the median. It is the value such that the distance from all the values to the mean is basically being canceled out on either side. So the distance from the mean up to 8 and up to 10 is the same thing as the distance down to 4, 3, and 2. Okay. The last thing to discuss in this video is how the mean and median relate to each other in a skewed distribution. If the mean ends up being less than the median, then most likely you have a skewed left distribution, with a lot more larger values than smaller values. Skewed left is kind of like saying we have a few outliers on the low end, and we already said that the mean is very sensitive to outliers. So those outliers are going to be bringing the mean down, but not really affecting the median. So if you find the mean and the median, and you find that your mean is quite a bit smaller than your median, then most likely you have a skewed left distribution. On the other hand, if you find the mean and the median, and they are either equal or very close to equal, then most likely you have a symmetric distribution. Not necessarily a normal distribution, as the picture shows. It could be uniform or something else, but in many cases it may be normal or bell-shaped. On the other hand, if you have a mean that is quite a bit larger than your median, then most likely you have a skewed right distribution, with a lot more smaller values than larger values. This is kind of like saying we have a few outliers on the right-hand side, which are going to be affecting the mean quite a bit more than the median. The mean is much more influenced by the skewness of a distribution than the median. So the way I remember this is the mean is going to be in the direction of the skewness. So if the mean is greater than the median, then you have a skewed right distribution, and if the mean is less than the median, then you have a skewed left distribution. All right, that's all I have to discuss in this video, so I'll see you in the next one.